Yes. Hi everyone, I am SS Kiran. I am dealing course is electronic devices and circuits. Okay. In this course, I would like to discuss about problems on JFET characteristics and transistor characteristics. Okay. Let's read the first problem. A JFET has VP, pinch of voltage is minus 5 volts, IDSS equal to 8 milliamperes, VGS equal to minus 2.5 volts. Determine drain current GM naught and GM. Okay, let's do the solution. Okay, first keep solution. For every problem you have to write the given data. Okay, what is the first formula for JFET characteristics? So ID equal to IDSS into 1 minus VGS by VP whole square. Okay, this is the formula. What is the IDSS value? IDSS is equal to 8 into 10 to the power of minus 3 milliamperes. 1 minus, what is VGS value? VGS value equal to minus 2.5. What is the VP value? Minus 5 volts. Okay, then whole square. Just doing some small mathematical part, you can get ID equal to 2 milliamperes current. ID equal to 2 milliamperes current. Then examiner asked what is the GM naught value. Okay, very simple. So GM naught equal to minus 2 IDSS by VP, minus IDSS by VP, right? Minus 2 IDSS by VP. No, so VP, so this is minus into, what is the IDSS value? 8 into 10 to the power of minus 3 by, what is VP value? That is 5 volts. So minus minus get cancelled. The GM naught value equal to 3.2 ohms. Okay, that is transconductance. Okay, GM naught. Okay, you have to write ohms, right? This is the GM naught value. Once if you get the GM naught value, it is very easy to find GM value also. Okay, now at final, GM equal to GM naught into 1 minus VGS by VP. Okay, we have already derived the derivation part in the general class. So GM naught equal to 3.2, 1 minus VGS value, you know very much, minus 2.5 by, what about VP value? Minus 5. Just doing some mathematical part using calci. So we can expect 1.6 ohms, or we can write a symbol also. This is the transconductance value. It is reverse transconductance value. This is the transconductance value. Okay, GM equal to 1.6 ohms, right? 1.6 into 1.6 ohms. Okay, let's start this next problem. A somewhat interesting problem. A germanium transistor IC not equal to 0.01 at 25 degrees. It is not at room temperature. Okay, alpha equal to 0.99. Determine the IC. So first, if you want to calculate when IB equal to 0.15 milliamperes, you have to neglect IC naught. Second time, you have to consider this IC naught. A third time, you have to increase 3 temperatures. One is the 50 degrees, other one is the 75 degrees, other one is the 100 degrees temperature. Okay, very interesting problem. First, I would like to find new IC naught value with the help of one simple formula. Okay, so now before going to this formula, first you have to, what examiner asked here, determine the IC value. Let us start the solution. Solution is IC equal to beta, IC equal to, one second, IC equal to beta into IB plus 1 plus beta into ICO dash. So here, why should I consider ICO dash? Here examiner asked at 25 degrees Celsius. So that here the ICO, actually, if you considered IC 0.01, so the new ICO dash implies new ICO dash equal to actual reverse saturation reverse ICO into 2 to the power of difference of the temperature T2 minus T1, T2 minus T1 by 10. These are all you have to write in the power part only. 2 into T2 minus T1 by 10. Okay, what is the IC naught value? IC naught value equal to 0.01, right? So 2 into some temperature calculations, 25 minus 25, room temperature 27 by 10, doing all mathematical calculations, the new ICO value equal to 0.0087, 0.0087 milliamperes. If you want to convert, simply some 87 microamperes, right? Now, this is the new ICO. So if you do with the first problem, if IB equal to 0.15 microamperes. So very simple. Here I have considered when IB equal to 0.015. So in this time ICO is neglected. So once ICO is neglected, so what we can do? Simply we can write IC equal to what is the beta value? So here beta is not given, alpha is given. So what is the formula for beta? Beta equal to alpha by 1 minus alpha. So beta is not directly given. Beta equal to alpha by 1 minus alpha, right? So equal to, what is the formula for alpha? Okay, just 0.99 by 1 minus 0.99. So a beta value is around, I think it's around 99. Just you can take direct value. There is no problem. That is the beta value. So IC equal to beta into what is the IB equal to 0.015. That's the IC value is, that's the final IC value is 14.85 milliamperes. Okay, this is the IB value. So second condition is ICO is considered. Very important. Second condition is ICO considered. So IC equal to this ICO considered 14.85 milliamperes plus ICO also considered. So 1 plus beta means 100. 1 plus beta means 100. What is the ICO value? This is the ICO value 0.0087 milliamperes. Doing all mathematical calculation, considered of the IC, the new value of IC 15.74 milliamperes. Okay, now what happened? So in the examiner strictly concentrated on if beta remains unchanged and the beta is as it is fixed, find the new value of IC when temperature raises 50 degrees 75 degrees, 100 degrees. I will do a little bit fast. Okay. The first condition is ICO dash with respect 50 degrees. With respect 50 degrees, I will write directly ICO into 2 to the power of T2 minus T1 by 10. What is IC naught value? Already examiner is given 0.01. So 2 into new temperature, 50 minus room temperature by 10. Okay, doing some mathematical part. Doing all the mathematical part, we can expect 0.0492 milliamperes of current if temperature increased to 50 degrees. Okay, if temperature increased, for example, 75 degrees Celsius, 75 degrees Celsius, then the new value is 0.27 milliamperes. You have to do as same calculations, just T2 replace with 75. If you want 150 degrees Celsius or 100, examiner asked about the 100, right? Yes, examiner asked about the 100. So very simple. I will do this one. ICO naught 100 degrees Celsius equal to ICO into 2 into T2 minus T1 by 10. So 0.01 into T2 into 100 minus 27 by 10. Okay, doing some all mathematical calculations by using calci. ICO at 100, you can expect 1.57 milliamperes of current. Okay, that is the new ICO at 100 degrees temperature. Okay, at final, what examiner asked, if find the new value of IC. So very simple. The first expression, IC at 50 degrees temperature. IC at 50 degrees temperature. What is beta IB value? Already I have find beta IB value 14.85 plus 1 plus beta value is 100. Okay, the new ICO value equal to for 50 degrees centigrade 0.0492. 0.0492. 1 second, I will write neat way. 0.0492 equal to 19.77 milliamperes current. So for example, if you take IC at 75 degrees Celsius, so actual 14.85 plus 100, 1 plus beta value. So the new ICO not at 75 degrees 0.27. Okay, if you're doing mathematical calculation by using of calci, you can expect 41.85 milliamperes current. Okay, now again IC at 100 degrees Celsius, IC at 100 degrees Celsius. What is the beta IB value? 14.85 plus 1 plus beta value 100. The new value is ICO. Actually, this is the new value of ICO 1.57 milliamperes. Doing some mathematical part, you can expect to 171.85 milliamperes current for increasing of this 100 degrees Celsius. Okay, just go through this procedure, so it definitely helpful to all competitive exams. Okay, thank you so much. Keep watching. I will update more videos shortly. Right, thank you.